on average rate of change. And in this case, we're going to focus on finding the average rate of change for graphs. In the last episode, I just did the change of x and the change of y. But I'd like to this time look at what it looks like when we're dealing with function notation. So let's look at it. In function notation, the average rate of change looks more like this, where we have f of b minus f of a over b minus a. So we'll be given a function and then given a and b, areas to look at to see where they are the same. Let's look at the first example. So in my mind, what I'd like to do with this one is I like to think of the negative a something like a barrier or a zone, right? And what I'll do is I'll find where a, all of the values where a equals -2. So I go on the graph, and this is like the input or x. So I would go along here, and I would look somewhere along this line to see where it crosses the graph. The next one I'll do is b, which is 2. And so I'll do the same thing. I'm going to look where on the graph these intersect. And I can identify these places as -2 for this one, -2 and -2. And the place for this one is 2 and 1. Okay, that will really help things out a lot in my mind. So we're looking at where f of a, which is really f of -2, it's just the value of a. We want to know the output, so we come here and look at this point, and we notice the output for this is -2. The output for the other case is if we put 2 in, we get an output of 1. Now the task is to take the difference between those two. So I start with b, which is the value right here, which is 1, and then we subtract a. So in this case, subtracting a negative gives a +3. Okay, and on the next one, we're going to do, we're taking b, put it first, and then we take a, put it second, and we're going to subtract a from b. In this case, that is 2 minus a -2, which gives 4. Looks like a 9. All right, so then we go ahead and plug it into the average rate of change formula, putting 3 on the numerator, or the top, and 4 on the bottom, or the denominator. Let's convert this then to decimal so that we can compare them later on. So this would be 0.75. Now remember, for all of these, unless it is specified otherwise, always round to the hundredth. Okay, now that was an example not of an exponential function. That's an error. This should be linear. Let's look now at a truly exponential function. Okay, so this one is an exponential function, and we're doing the same kind of thing. This one's a little tricky because, as you'll learn in later lessons, this is what we call an asymptote. It's kind of a preview. That means that this line gets closer to, but never quite touching 0. So when we're looking at a of 0, then we're looking at something that's approximately 0. It's getting really close to it in this case. And so that's what we'll call it. But we're going to have to note that by putting this little symbol here, which means it's about. So at a equals 0, the function is very close to about 0. And then at 9, so we're coming over here and counting 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We come up to the top here along 9. And this is 8 high, so this would be 9 in the x direction and 8 in the y, or the height. And so the output, given 9 is the input, the output is 8. So now finding the difference will be approximately, because of the 0 that we're knowing that's about there, we're going to take 8 and subtract 0. which of course gives us about 8. And we just have to remember that now these are going to be just an approximation. It's close enough for what we're doing, but that's something we just need to note. Now let's go ahead and do 9, and these are concrete. So we know them. We don't have to do approximate. This is 9 minus 0 is 9. So then we go ahead and write this as 8 over 9, noting that it's an approximate. And then we get, as a decimal equivalent for this, is approximately 0.89, rounding to the hundredth. Okay. Interesting that we had that. We'll talk more about asymptotes on a later lesson. All right, so let's go with the next one. The last one is a case where instead of having exponential, this should be other. And so we're going to evaluate this function that doesn't fit in either case at a equals -6 and b equals 0. So we're going to go to -6, which is 1, 2, 3, 4, 5, 6. So it's right here. And at b equals 0. Now this function does indeed pass through 0, and this one passes through, looks like 2. So our location at the first one is 0, 0, which is the origin. And then, not the first one, but at b. And then at a, this is -6 and -2. That helps me identify what to put in which place. So at f of -6, we of course get the output of -2. And f of 0, we get the output of 0. Now we're going to take the b value, which happens to be 0. So we take b and we subtract a -2, which makes this a +2. Now we do something similar with the denominator, or the change in x on this case. And so we'll take b, which is 0, and we subtract a -6, which gives us a +6. Now we go ahead and put the 2 on top and the 6 on bottom. This does simplify to 1/3, but we want to put this into a decimal form so that we can compare them later. So we'll take 1 divided by 3, which gives us 1.33, rounding to the nearest hundredth. Or if we want to do the exact amount, we can do a line over top if we have that option. Okay, that should do it. That's enough to get started on the assignment. If you have any more questions, please consult with your teacher.